now. So
I
there's been some developments with the tests. I'm sure you're aware of the crazy ideas they're having with the AP exam, and having you take it at home, maybe watching through your cameras to make sure you're not cheating and capturing your screen and stuff while you're doing the test. So a lot of weird things going around, but what we know for sure is that they cut some of the content out of the AP exam, and it's kind of frustrating because I changed a couple of units around at the last second, because we did simple harmonic motion and I went right into mechanical waves. But ironically, mechanical waves will not even be on the exam. I jumped over this unit, the rotational motion unit. So that is going to be on the test. So we're gonna talk about the speed of sound lab today, but then we're not gonna do anything else with mechanical waves and sound. We're just gonna pass that lab in. 4 of you have already passed it in, and so we'll talk about it and figure out the lab, and then you can turn it in. But that's gonna be like the only grade in that whole unit, and we're gonna switch to rotational motion. Okay. So. Another unit that we were supposed to do was static electricity and charge with DC circuits. That's this unit. Kyle already has it. We're not going to touch it, Kyle. So you can get rid of that. Kyle also already has rotational motion, which is good because we already
that one. I'm sad. I'm devastated,
Oh, I'm sure you are, yeah.
Yeah.
What a shame.
Tears. So we're gonna pick up on this unit starting on Thursday, and you should be getting it in the mail today or tomorrow if you didn't come into school to pick up your packets. But you'll also get this packet in there as well. You can just set that aside. But we will be focusing on this one, okay? So,
toilet paper.
Yeah. Oh, that's what I should have sent you. We have plenty in the school.
That's gross, Sam.
I don't know. Is it really that gross? I'm not going to use the toilet paper first. It's going to be fresh. So none of this stuff will be on the exam. It's looking more and more like it's just going to be a multiple choice AP exam, which is very strange. And we'll be trying our best to study for that after we do the rotational motion unit. But just so you know, everything else we've done this year is going to be on the exam, but we haven't done rotational yet, so we'll do that. And then we'll be able to study for a test that will be totally different this year. I think they just want their money, is what they want.
Probably.
Those tests aren't cheap, so just checking to see who we have here. We have almost everybody.
Tommy's on his way.
Tommy's trying to join right now.
Oh, he is?
Yeah.
All right, good. Maybe I won't have to record this. Maybe everybody will just kind of get it. So, yeah, it's weird being in the school. I'm sure it's kind of weird trying to do school at home, too. But this whole thing is pretty challenging and strange.
Yeah, it's not that bad.
That's good.
It's not bad until your teachers bombard you with like 10 assignments in one day and say, hey, do it now.
Yeah, basically.
Well, Richmond was saying that you guys aren't supposed to give out, or like they like weren't supposed to give out work right now, or new work.
No,
right.
It's not new work.
Yeah, we're not supposed to do new work.
Yeah.
Starting next week, though, we can. So.
Yeah.
So we're gonna start looking at the lab stuff just a little bit. I know some of you have already finished it up, but I just wanted to cover a couple of quick points. Kat asked me about this yesterday, but there's a really simple equation to find the velocity of the sound waves. And that's, you need to know the frequency and you need to know the wavelength. That's wavelength. So if you remember from the lab, we had a whole part of it that was looking at, you know, changing the density of the material that we're making the waves through, changing the frequency, the harmonics. All that stuff is just kind of, it's not calculations really, it's just kind of talking about in the first part of the write-up how those different things that we changed, how it affects the speed of the wave. But this equation really does indicate that it's only really got to do with frequency and wavelength. And that's what the second part of the lab was about. So I drew this on the board, but I don't know if anybody grabbed a picture before we left.
Tommy's here now.
Okay, good. Hey, Tommy. That's a tuning fork.
Wonderful.
Yeah. All right. So when you, you know, bang the tuning fork against something, it makes the waves compress and, you know, expand. And inside of this, we had the water inside of the graduated cylinder. Somebody's dog is barking. Now, what happens inside of the tube is we actually only fit like a quarter of a wave. So the wave inside of there is going to be a quarter of a wavelength, or sometimes you actually end up with it being a half of a wavelength that fits inside of there. And it's because it's open at the end, right? Like a complete wave would go like this, but these nodes don't have any sound, right? So like the maximum audible volume would be at the max here or here. So either we have, you know, 1/4 of a wave. Oh, actually, no, it would be, the other option would be 3/4 of a wave. So not 1/4, but 3/4. I don't think any of us actually had 3/4 of a wave, just because there isn't enough like room, like we didn't have a big enough graduated cylinder to do that. But, you know, let's say that you had 1/4 of a wave and it was, you know, 31 centimeters or something like that. Okay, so like this measurement from the top of the tube to the water was 31 centimeters. Okay, that has to be in meters, but it does go into this equation. And you also have to know the frequency of the tuning fork. So the tuning fork will have the frequency right on it. And you just multiply the frequency of the tuning fork by our wavelength. So if it's actually 1/4 of a wave, then it's going to be 124 centimeters for a full wave. Which is 0.124, I mean, sorry, 1.24 meters, which is why, you know, we didn't have a tube that tall. So that's why we're only getting, all right, then you just multiply those together. Oops. And 125, I just made up these numbers, so they're probably going to be awful, but yeah, that's really bad. Why are the units meters per second on that?
Because it's velocity. Did you already multiply it by 4?
Yeah, I did that down here. What is the units hertz?
periods per second.
Yep. Yeah, so this is per second, basically. It's like 1/seconds for hertz. And that's meters. So meters times 1/seconds is just meters per second. Okay. Does anybody know what the speed of sound should be?
Like
Like-
300 something.
Yep.
340.
Yeah, it's around 340. So that is not equal to 343. Okay. But in your experiment, hopefully you are pretty close to that 343. That's at 20 degrees Celsius, by the way. We also, and I can't wait to see how this turned out, but we also had a part of the lab that you did outside at a different temperature. So it was colder, so the speed of sound outside should actually be faster because the air is like closer together. So you can actually look that up on they have tables for that, so you can see what the speed of sound would be in different temperatures, but that's at standard conditions. So 343 is for 20 degrees Celsius, which, you know, I think the room was pretty close to that that day. It was pretty cold outside. I'm trying to remember. Boy, it was a long time ago, but so you should be seeing an increase in your speed of sound outside. So yeah, there's a lot of parts to the lab because we had the whole beginning part where you were looking at changing frequency, changing wave density, changing all those aspects and looking at the speed of the wave. And then we had calculating the speed of sound inside with the tuning forks and the water. Isabel did this outside too, so it'll be interesting to see what her numbers look like after she did this lab outside. And then we had other people like honking their horns and trying to like time it. So do make sure you tell me what your procedure was for outside because I didn't get to see everybody, you know, doing that part of the lab. So.
I mean, I didn't get you either. It's
Well, just yell from your house, Kyle. I'll time it for mine.
okay. I don't think I'm that loud. I'm close, but no.
Well, you've got all that pent up, like singing angst to get out. You can just like, yeah.
You know, you're right.
I mean, your whole play and everything was just, your whole lives are put on hold. I feel so bad for you seniors. It's crazy.
Yeah.
So I think we're probably good with the recording, so I'm going to stop there. That way I can keep it short.